Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In our previous video tutorial, we developed a multiple regression function or multiple regression equation where we modeled our dependent variable on 3 independent or explanatory variables. In this case, our dependent variable was minimum temperatures, monthly minimum temperatures, and our explanatory variables was constant, time, and maximum temperatures. So we developed a regression model for that, and we generated that through using OLS within Earth Engine, and we generated an image and coefficients for a region of interest as a whole, but also for each individual region as we selected by the inspector. Okay, so this is basically what we've generated. Okay, we've initially generated a time band. Remember, we had a discussion on the number of zeros there, and where Excel is very helpful in determining the correct number of zeros. But also remember, these things must make sense. Always remember logic and relevance. Okay, and then as I said, we've developed an equation with our dependent variable, minimum temperatures, and our 3 independent variables, constant, time, maximum temperatures. And then we run it through a linear regression, a robust linear regression, and we displayed these images on a single, we displayed these coefficients on a single image for our region of interest as a whole, but we also generated the coefficients for the different locations as we select them by the inspector. Okay, so what I'm going to do in this particular video tutorial is I don't want to include time. I want to rather include another explanatory variable that's within the image collection itself, which is, in standard OLS, you normally have your dependent variable, a constant, and then several or number of explanatory variables, which is variables per se. It's not time. Okay, so this is what I want to do here. And in this particular case, I want to work on this equation, this model, this function. Remember, in Earth Engine, the independent variables are first, and then a dependent variable follows. Okay, so I'm working with my dependent variable, which is PR. Now, what is PR? PR is there. It's participation. Okay, remember, scaling factor is no scaling factor, so it's scaled by 1. There's nothing. It's 1. Okay, so remember, that's PR. So I'm going to model rain or participation on a constant, maximum temperatures, and VS. Okay, maximum temperatures we've dealt, and VS is a new one, which is wind speed. Okay, if I go to my landing page, you see there's maximum temperatures. Okay, you see it's a scaling factor of 0.1. Okay, so issue 1, participation have no scaling factor. Maximum temperatures have a scaling factor. And then you have VS here, which is wind speed at 10 meters above ground, above surface. And its scaling factor is 0.01. So now I've got 3 variables, each having different scaling factors. But what is important, you always choose the scaling factor of your dependent variable. Okay, so always choose your scaling factor of your dependent variable, because you cannot scale a single image collection with 3 different scales. It's impossible. You cannot do that. Okay, you can only scale your image collection with 1 scale. Okay, like we've done previously. Because maximum temperatures and minimum temperatures have the same scaling factor, we just use 0.1. But in this case, there's 3 variables that have different scaling factors. So which scaling factors to use? You use the scaling factor of your dependent variable. And in this case, it doesn't indicate, so we use 1. Because if 1 and a no scaling factor is exactly the same thing. Okay, so I'm going to use a scaling factor of 1. There it sits. So I'm saying that with that rainfall or participation is a function of maximum temperatures, heat, and wind speed. Okay, Now, if you stay in the West Coast, the wind should make sense because the more the wind is, the more it rains. When there's no wind, it doesn't rain, especially the northerly wind. Okay, but anyway, so I'm saying that there should be a positive relationship between rain and wind speed. However, there should be a negative relationship between heat and rain because it's a winter rainfall season. So when temperatures are high, that's the summer, we don't get rain. When the temperatures are low, that's winter, that's our rain. But also, the rain comes with the winds. So that should give you an indication of what I'm expecting my signs of my coefficients to be, etc., etc., etc. Okay, so I don't have a time stamp. I don't have a time variable, so I'm deleting it. Remember, that's what we generated our time. In this case, I don't have it. I only start with a constant. So I have my constant. I have my data set or data product, which I clip to my region of interest. I scale it with a factor of 1, meaning there's no scaling, and that's because my dependent variable is scaled by 1. I still include my time properties, although I'm not using it. I'm still using it for if I want to do it. Okay, I've got my period. I add my constant, and then I select my equation. So my equation is, remember, we work from right to left, not from left to right. Participation is a function, positive wind speed, negative maximum temperatures, and a positive constant. Okay, so that's what I'm hypothesizing, or that's what I'm modeling. We create our equation, so that's our model, but now we create our equation because now we're telling it there's 3 independent variables, 3 independent variables, or explanatory variables, 1 dependent. That's for our linear regression, and similar for our robust equation. We've got our bands. Okay, there's our bands, which is our independent variables and our dependent variable. Then based on our bands and our equations, we generate our coefficients. Okay, and that's the coefficients that will be displayed when we print the coefficients for our region of interest. And when we use our inspector, that will be the coefficient. So each and every single location will have coefficients, and then my region of interest will also have a coefficients, but as I said, for the region of interest as a whole. There's my parameters for my image. Okay, there's my parameters for my image, similar to the previous one. Obviously, we're going to play around with the color scheme a little bit. So play around with the color scheme. We know that we can either play around with that and run it, or we can simply go to OLS there, and we can simply just click on the nut there, and we can play around with changing the visualization parameters in this option here and play around. We're going to do that now. And then obviously we're printing our coefficients, but here we print it for our region of interest as a whole. That will appear in our console. Okay, that will appear in our console. Couple of things to remember is 1 hour scaling. 1 hour scaling. Okay, well, so let's start. We don't have a time, so we delete the time. Okay, our scaling factor, we apply the scaling of our dependent variable. We specify our equation, and then we model our equation for our linear regression and our robust linear regression for coefficients. We create our band names for which we're going to generate the coefficients. Then we display those coefficients on our image, and we print those coefficients for our region of interest to our console. So that's basically what we're doing here. Now, what I've also done is, just to give you some indication, is I've generated the images, median images for 3 of my variables. Okay, so I've created an image, a medium image for participation. I've created a medium image for wind speed, and I've generated a medium image for maximum temperatures. So if I use my inspector, so while we're waiting for these images to load, if I use my inspector, let's click on this specific location. Let's see what the numbers look like. Okay, just to put those variables into perspective. So my rainfall at that location is 16. That would be 16 millimeters, and it's not scaled. Okay, so that makes sense. Wind speed 442. Wind speed is meters per second. Now 442 meters per second. That's that's again, it doesn't make sense. You should think it doesn't make sense at all. Why? Because it's an unscaled value, so we have to scale it. So it's actually not 442 meters per second, it's actually 4 meters per second. And then, as I said, maximum temperatures is 464 for 246 degrees Celsius. Now again, nothing will survive that. We'll all be dead, fried, bacon. So that doesn't work. So again, go to your data product, go to its bands, and you'll see it must be scaled by 0.1. So in fact, that value there must be 24.6. So that means that that location has a participation of 16. It has a wind speed of 4.42 meters per second. It has a maximum temperatures of 24.6. Let's have a look at that location. Okay, so I'm using that location. So that location will have a participation level of 18 millimeters. Remember, these are now medium images for the whole image collection for all the months. Okay, so not the average, a median. It will have a wind speed of 2.8 meters per second, and it will have a maximum temperature of 26.9 degrees Celsius. And the images, there is the temperature image, there is the wind speed image, there is the maximum temperature image. It's still loading, but it's coming. Now just remember, in our color scheme, we start with dark blue and we go to dark red. So the darker the colors, the more extreme they are. The lighter the colors, the more in the middle they are. Okay, so remember that. Okay, so dark colors will have dark red colors will have high rainfall. Dark colors, where it's dark red colors will have high rainfall, high wind speed, and high maximum temperatures. Dark blue will have low maximum temperatures, low rainfall, and low wind speed. Middle colors, obviously, because that's why we created the color scheme. Okay, now you can change the color schemes so that each one of those variables have its own color scheme, because it's a bit counterproductive to use the same color scheme for 3 variables. That's very different. Okay, so in fact, ideally you should have a color scheme for each of those variables, and not for one color scheme for all 3. If the 3 variables are similar, fine, use the same color scheme, but you can see they're very different. So in fact, you should use different color scheme, especially for rainfall, which is, compared to the other 2 in absolute terms, much different. Okay, so it's not ideal, but as I said, the point is just to show you what the actual numbers are for each of these image collections. Okay, what the numbers are for each. So when we work with the coefficients, then these things make a bit of sense. Okay, so now we've generated the individual ones, and it's for median for the whole period. You can change that. As I said, then we generate the coefficients for our region of interest as a whole, and then obviously for our individual locations. Okay, so let's quickly have a look and see how that plays out. Okay, if we, for example, go to our inspector and we choose a location, let's choose this one, that's dark red. Okay, so let's, it's OLS now, sorry, OLS is not collected. So let's go dark red is here. Okay, so let's go that one, dark red. Okay, so let's use that location as an example. So that location, the rain participation is 18. So I'm going to go to my Excel and I say my participation is 18. So what I've done in Excel, I've already created a little spreadsheet, and column A is the scaling parameters, B is the variables themselves, and C is the actual values. Okay, and then this is the modeled values, or the model value is that one, and the coefficients. And obviously the modeled value, this one here, should be as close as possible as the actual value, and the difference obviously is the error term. Is the difference there is the error term between the actual value and the modeled value. So that would be the error term. Okay, so I hope this makes sense what I've done here. Okay, I hope this makes sense. So we've got the actual value 18. So then we've got our wind speed 306.4, So wind speed there is 306.04. Let's just change it to comma. And then my maximum temperatures is 246. So let's make that 246. Okay. Now I need to add in. Okay, so the scaled values. Okay, the scaled values are not 246 maximum temperatures, 24.6. It's not 306 meters per second. It is 3 meters. But I'm not using this in my equation. I'm just showing you what the actual values is. So it's actually 18 and 24 and 3 meters per second. That's the actual values. But in the model, in the image collection, that's the values themselves. Okay. But anyway, that's it. So remember, we use these values in the model, not the scaled values. Okay, because the coefficients are calculated based on these values. Okay, so let's quickly add in the coefficients. So the constant is 103. So that's the constant there. Okay, and you can chart it as if you want to. It's not going to look nice because this one will just overshadow it. It will just be a bar chart. Okay, so we take that and we copy it in there. There's the coefficient, the constant, coefficient of the constant itself. There it sits. Come on, it must be, what is it again? I forgot. 103. Must be a comma there. I forgot the comma. And then we've got maximum temperatures. And now, interesting enough, you can see maximum temperatures are minus, né? There it sits, which is what we are looking for. We're looking for minus. It needs to be a minus because the hotter it is, the less it rains, because we have a winter rainfall, cold when it rains, cold, cold, cold. And then we have wind speed. Okay, we need this wind to blow for it to rain, especially the northerly wind, and that's positive. So the signs is what we expect. The coefficients are what we expect. And you'll see there, that's the actual value. The modeled value is 24 and the error term is 6. So let's quickly do this now. And let's quickly generate one in a lighter area. Let's say that was very dark area. Let's say this seems like a lighter area here because this is on top of the mountain. Eh? So let's have a look there. So that's in the middle of the veld in the bush. It's very hot. And this is on a mountain, so it should receive more rain. Yep, it's on the mountain, so it should receive more rain. Let's make it there. That's 20. And then its wind speed is 329, so that's quite a bit higher. So that's already starting to make sense. And then the maximum temperature should be cooler, 248. Because it's on top of a mountain. Well, roughly the same. But you can see the wind speed has picked up. The maximum temperature is roughly the same and the rainfall has increased. So that indicates to you already. So there's our scaled values. Okay, so that's our scaled values. Remember our dependent variable scaled by 1. Now let's add our coefficients and see what transpires. So there's our constant. So let's add our constant in there and paste it in there, comma, and then our coefficients for maximum temperatures. Again, minus there. You'll see there, minus, right? As we expect, it should be a minus. Let's add it in there. So here a bit bigger, né? Oh, smaller. So coefficient is smaller than the previous one. And let me guess, this coefficient should be then a bit bigger than the previous one. Yep, it's a bit bigger. So all of this seems quite logical to me. And the modeled value is 26. You see the error term is roughly the same. It's like a bit smaller. So that gives you an idea what we're doing here. We're actually developing a model for rainfall for each of these locations based on these coefficients that we've generated using our model for those variables. So that's what we're basically doing here. As I said, exactly the same as what we can do in Excel. And I said, I like to work with it in Excel so that it makes sense to me, these numbers. Now, as I said, you see why it's important that we use the scale of the dependent variable. Okay, so that the scaling doesn't become an issue. Okay, otherwise we're going to run into problems. Now, as I said, we can play around with save. We can play around with the numbers here. So for the colors here. So again, we're working with OLS. Let's say we're making this number 10. Let's see what happens if I make that 10. Okay, so let's just select those other variables, make it a little bigger. I hope it goes quickly. Let's see what happens. Might take a bit of time for it to come through. But yeah, so you can play around with these values here to get to a color scheme or visualization that actually makes sense. Okay, that you can work with. Okay, so here still it's just going to give us our reds. Okay, so let's go back to make it 30 there. If I make this number minus 30, let's run it again and see what that. I'm going to keep it small so that it doesn't take too much time to load. If we change, so that's how you do that. You just change these numbers and then see what happens until you have a color scheme or a visualization parameter scheme that actually makes sense. Okay, so again, the red. So that's not going to make much of a hoo-ha. That's it. What you can do is you can go into the nut itself here and go there and say, okay, I think this stretch 100%, I think was the one that actually made a bit of a difference. Okay, so we're stretching it 100%, and let's close it. It's going to give our image now in terms. And remember, this image you can export. You can export this image to QGIS, and you can continue working with it. Now, visualization is not going to work very nice, but in general, we said that the dark red is this scenario, low rainfall. And the light red is this scenario, which is high rainfall. Okay, so the dark red is this scenario, and the light red is this particular scenario. So you can figure out the color schemes using Excel as well. Okay, so yeah, well, that sounds quite nice, if I may say so myself. Remember, the inspector is for the individual locations as selected. The console, these numbers are for your image as a whole. Okay, it's for your image as a whole. Now, we have our rainfall, so we can put these numbers in as well in terms of these numbers, because remember, these numbers are this is per location, so we can't actually calculate these ones for the image as a whole. So we can't remodel this. But nonetheless, I think you get the point. Play around with the numbers, play around with the visualization parameters, play around with the variables, and see what it happens. And as I said, use Excel. I like working in Excel because then it starts making sense to me. Okay. Well, thank you for joining me on this journey. I appreciate your company. Thanks for sharing your wonderful comments and ideas in the comment section. Please feel to send me comments. I'll happily look at it and respond to it. Please remember to like, subscribe, and share. Remember, sharing is caring. And I'll see you soon. And as I always end off, I'll see you on the other side.